So in AZ, a BZ, a CZ, we had the weight of the barrel or the drum that it's holding, which is ultimately what we need to find, is how much we can apply before it tips. And then the weight of the crane itself we did include in this problem, and we were told where its center of gravity was, and 300 pounds was its value. So in the equilibrium equations, we sum forces in the x, and we got 0 equals 0. We sum forces in the y, and also got 0 equals 0. And then we summed forces in the z direction, and this is where we have AZ plus BZ plus CZ minus W minus 300. So equations 1 and 2 don't help us, but they are true, so that is required. So we have really one linearly independent equation, and we have 4 unknowns at this point. All right, so we need 3 more, we'll get 3 more equations out of our equilibrium. And so far we haven't applied any knowledge, or we haven't used the fact that we're looking at it when it's on the verge of tipping. We're going to do that as we go through the math here. The free body diagram doesn't know anything about being on the verge of tipping. This is what it looks like if it's in static equilibrium. All right, so if we take the sum of moments around a point, it will be equal to 0. So in this case, what would be a good point to take the sum of moments about? Yeah, so there's in this one, no obvious point. There's no pin, there's no built-in connection, there's no ball and socket. So A, B, and C all have one unknown, so our best bet is one of those. So in my notes, I chose C, but A or B would be equally as good if we're doing this by hand for this. So for the sake of my notes, let's choose C. All right, so if we're taking the moments about C, then what will the right-hand side of our equation be for the moment about C? So what contributes to the moment about C? So in mine, I called that point D, where the barrel is acting. So I'll use RCD, and that's crossed with. So that's from the weight of the drum that it's holding. At D, the weight of the barrel, right, in this case, we don't know that. It's going to be W, and that is in the negative K direction. All right, so Z is up, this is pointing down. So negative WK. And this one we didn't need to use unit vectors because everything acts really just in the Z direction. All right, so the moment caused by the weight of the drum it's holding, we don't know the weight yet. What else contributes to the moment around C? All right, so the normal force at A, so RCA cross AZK. And then the same thing at B, RCB cross BZK. Right, so this is where that the weight of the crane comes into play. So I named that point G, so RCG cross negative 300K. So we have 4 cross products here, and we have 4 different position vectors, so there's no way to really condense them. So I won't go through all the math steps here. But just like we've seen in previous examples, we get IJK, 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 etc. Group all the I terms, all the J terms, all the K terms. So if we expand all of these cross products out, we get negative 2.5 AZ plus 2.5 BZ in the I plus 900 minus 7 AZ minus 7BZ plus 9.66W J plus 0K. Right, so pulling off those coefficients, we get negative 2.5 AZ plus 2.5 BZ is equal to 0. So now mathematically this does tell us that AZ is equal to BZ. I did not in my solution assume anything about the symmetry. Even though we can see it is symmetrical, we should expect that AZ and BZ are equal. This does show it, but I highly recommend don't assume this up front, because if it turns out not to be symmetric, you can't get the right answer if you impose symmetry and it's not. So it is symmetric. AZ does equal BZ according to equation 4. Pulling off the J terms, we get 900 minus 7AZ minus 7bz plus 9.66w is equal to 0. If I put equation 4 into equation 5, I get that az, since it's equal to bz, they're both equal to 64.3 plus 0.69w. If I then put this into equation 3, I can get CZ in terms of W. So CZ will be 171 minus 0.38 W. And the sixth equation, the K terms just tell us 0 is equal to 0. So if we look at the 6 equilibrium equations, only 3 of them are linearly independent. But we do have 4 unknowns. I did some rearranging using equation 3, 4, and 5 because of the circumstances we have. So I have all of the normal forces in terms of W, but as numbers, I don't have anything yet. But they are rearranged, and it'll be nice in the next step. So I've used all of our equilibrium equations. Those are done. Now, what haven't we? What do we know that we haven't used yet? Yeah. Right. So this is what I call the tipping equation. So our supposition is that when this is on the verge of tipping, that because we're putting weight in the drum at D, that the wheel at C is going to start to lift off the ground. So we're going to say that in our tipping equation, we are analyzing this when CZ is equal to 0, meaning that's just on the verge of tipping. It's just lost contact force between the wheel at C and the ground at C. So this gives us a 7th linearly independent equation. CZ is equal to 0. Now if we put equation 7 into equation 3, now we can get a number out because now CZ is 0. So putting this into equation 7, or 7 into this, we'll get that the weight that causes CZ to just be 0 is 450 pounds.